Okay, so this is my quadratics function. It deals with falling objects. It is to assume a 2G environment where gravity is 19.62 meters per second squared with no air resistance. If Frederick throws a coin upwards at 1.4 meters per second squared on top of a bridge 20 feet off of the ground, with the release point 4.5 feet off of the bridge, when will Frederick's coin hit the water below? To solve this, first, we have to make an equation. The equation of falling states the negative half of the gravity, in this case negative 9.81, multiplied by the time squared, in this case x, added to the force, in this case positive 1.4 because Frederick throws a coin up, added to the starting point, in this case positive 24.5, is equal to the goal height, in this case 0, because we want it to hit the water below the bridge. The actual equation is negative 9.81 x squared plus 1.4x plus 24.5. Now keep in mind that x is the amount of time, which is what we're looking for. To solve this problem, we must use a quadratic formula which states that x equals negative b plus or minus square root of b squared minus 4ac all over 2a. In our case, b is 1.4, a is negative 9.81, and c is 24.5. Plugging in all of the values gives us two answers, 1.6533 and negative 1.5106. We can discount this negative 1.5106 because we are finding time, which cannot be negative. Therefore, our solution is that it would take 1.6533 seconds for the coin to hit the ground. The graph. This is our graph. The vertex is up here. The one possible route, which is not counted because time cannot be negative, is right there. And the actual answer is right there. Now notice that the vertex is actually not on the x-axis. The vertex is actually the highest possible point the coin can reach. And the answer is what happens when the distance reaches 0. This is my table. The x values, which are the time, are on the left, and the y values, which are the distance from the water, are on the right. For example, at x value 1, which is 1 second after the coin is thrown, y value 16.09 feet over the water. The solution is highlighted 1.6533. So to provide more detail on the quadratic formula, I'm going to be demonstrating on this TI-83 Plus. First of all, you have to do negative b, which is negative 1.4, plus or minus, although I'm going to be doing plus this time. I'll be doing minus next time. Square root of 1.4 squared, which is b squared, minus 4 times negative 9.81, that's a, 24.5, which is c, and then you get 29.63771899. Now you divide that by negative 19.64, sorry, or 62, and you get negative 1.510587104, which is one of the possible solutions of the quadratic. However, it's not the solution of the word problem because time cannot be negative. So let's try that again. This time we'll do minus. So we'll do the same thing, negative 1.4, negative b, but this time we'll do minus square root of 1.4 squared minus 4 times negative 9.81, 24.5. Now let's put that over negative 19.62. Enter 1.653, and that is the correct answer.